In today's video, we're going to look at finding areas of trapezoids and kites, as well as looking at finding the area of a composite figure, which we will see in a little bit. So first of all, a trapezoid is any quadrilateral with exactly one pair of parallel sides. So just as a reminder, a quadrilateral means four-sided figure. Okay, quadra being four, lateral meaning side. So quadrilateral means it has four sides. Now a trapezoid has exactly one pair of parallel sides. So you'll remember with our parallelograms, which include squares and rectangles as well as this style of parallelogram, you can see they have two sets of parallel sides where these sides are parallel to one another and these sides are parallel to one another. So each of these has two sets of parallel sides, whereas a trapezoid will have only one pair. So you'll notice here these are parallel to one another, and these, while it's not very well drawn, are parallel to one another. So that's a trapezoid. Now a kite, on the other hand, is a quadrilateral that has two pairs of adjacent sides with the same length and opposite sides with different lengths. So that might sound a little confusing, but if we look at this example, you can see what I mean. So we can see that this side here, which is adjacent to or next to this side here, they have the same length, as do these two sides here. Right? They are adjacent, meaning next to each other, and they have the same length. Whereas you can see the opposite sides, if we go back and draw this again, right? This pink side here, its opposite over here in yellow is not the same length. So that's a kite. Now, we can look at finding the area of a kite just by decomposing it, which means to break it down. So if we were to look at this, right, we can see that we could actually make two triangles out of this kite. We could, right, find this triangle that I'm highlighting in yellow, and if we find the area of that triangle as well as the area of this triangle, then we would know the entire area of this kite. So as a reminder, our formula to find the area of a triangle is 1/2 times the base times the height, 1/2 BH. So if we were to look at that, we've got A equals 1/2 of the base times the height. So let's look first, and in this case our kite is going to be equal to the area of our first triangle in yellow plus the area of our second triangle in pink. And I'll label those A1 and A2. So let's start with the area of our first triangle. So 1/2 times the base times the height. Now we can see 3 feet is labeled here as the height of that triangle. And then we can see each of these sections here is 4 feet. So that would mean our base for the triangle is 8. So you've got 1/2 times 8 times 3. We know that 8 times 3 is 24, so 1/2 of 24 would be 12. So the area of our first triangle is 12. So now we can find the area of our second triangle. Again, it has a base of 8 feet. And the height this time we can see is 6 feet. So 1/2 of 8 times 6. 8 times 6 would be 48, and we know that 1/2 of 48 is 24. So now we have area for the first one is 12, area for the second one is 24, and those are both feet squared or square feet. So the area of our kite will be the two of those combined, 12 square feet plus 24 square feet. We would get an area of 36 square feet. All right, now let's look at finding the area of a trapezoid. So the formula for finding the area of a trapezoid is 1/2 base 1 plus base 2 times height. So if we look at this here, right, we have base 1 is labeled as 5 feet, base 2 is 9 feet, and then the height would be 6 feet. So we can find 1/2 base 1 plus base 2 and multiply by the height. So let's go ahead and solve that here. Base 1 is 5, base 2 is 9, and then we'll multiply by the height of 6. So we know that 5 plus 9 is 14, so now we have 1/2 times 14 times 6, and we know that 1/2 times 14 would be 7, so our area is equal to 7 times 6, which means our area is 42 square feet. Finally, we're going to look at finding the area of a composite figure. Now, a composite figure just means it's made up of multiple shapes. So you'll see here we've got a few different figures and a few different ways we can solve this. So our goal here is to break this figure down into figures or polygons for which we know how to find the area. So for example, we could see if I were to create this line here, now I can see I've got a rectangle, and I could find the area of that rectangle, as well as a trapezoid, and I could find the area of that trapezoid. Okay. Alternatively, I could choose to make two rectangles and a triangle here. I could find the area of the triangle and the two rectangles. Okay, you'll just want to make sure you have to calculate some of these missing values. So let's go ahead and do with the trapezoid so we can practice that. So again, the area of this rectangle will be equal to the base times the height, and the area of this trapezoid will be equal to 1/2 base 1 plus base 2 times the height. Now, for our rectangle here, we can see we've got a height of 10 inches and a base of 5 inches. So if we were to multiply those, the area will be equal to 5 times 10. So our area of that rectangle is 50 square inches. Now, for our trapezoid, we know that the area will be 1/2 base 1 plus base 2 times the height. But we actually need to calculate our height here. So we know that this right here will be our height, and that's not a length that we are given. However, if I know that this length here is 10 inches, and this length here is 6 inches, then I can subtract 10 minus 6 to get 4 inches for my height. So now I have my height of 4 inches, base 1 and base 2, so I can solve for the area of the trapezoid. So this area will be equal to 1/2 of 7 plus 15 times 4. And we know that 7 plus 15 is 22, so 1/2 of 22 times 4, and 1/2 of 22, or 1/2 times 22 is 11. So we have 11 times 4. So our area of this trapezoid would be 44 square inches. So now we know that the area of the trapezoid is 44 square inches. And the area of the rectangle is 50 square inches. So combined, 50 plus 44, we would have a total area of 94 square inches. Let's look at one more example. So for this one here, we can see again, we've got a couple different options for how we want to solve this. I'm going to go ahead and draw my little dotted line here. So generally speaking, when you have a composite figure, you'll have a few options. And it's just a matter of preference and finding one that you'll be able to get the measurements for. So we need to know the height of this triangle if we want to find the area. Now once again, we can find that height because we can see this that I'm outlining in green is a rectangle, which means if we've got 7 inches here, then this whole length on the other side that I will highlight in yellow also needs to be 7 inches. So if that's 7 inches, and this shorter part here, or this piece of our figure here, is 4 inches, then we know 7 minus 4 will give us our height of our triangle, which is 3 inches. Okay, same thing goes for the base. Our base will be here, and we know that this whole length of this side is labeled as 12 inches, whereas this part of the rectangle is 8 inches. So if this from here to here is 12 inches, and from here to here is 8 inches, then 12 minus 8 gives us 4 inches for the base. So now we have a base of 4 and a height of 3, so we can find the area of our triangle. That's 1/2 times the base times the height. So 1/2 times 4 times 3. That would be 1/2 times 12. So the area of our triangle would be 6 square inches. For the rectangle, we can see that it is a base of 8 inches and a height of 7 inches. So 8 times 7 is 56 square inches. And once again, to find the total area, we just add these two areas. So the area of our composite figure would be 56 plus 6, which is 62 square inches.